Being the technologically advanced society that we are here in the 21st century, we would really like to believe that we've explored every square inch of this planet. But the fact remains that there are large portions of this planet that we have never seen. 2/3 of the Earth is covered by water, and a lot of those places are very deep. So because of the immense pressure that is created by this huge amount of water, we've been unable to send people or machines down there to explore that. So how do you think technology is helping us to better understand our oceans? That's what we're going to talk about in this section. Ocean Exploration, Section 1. In this section, we'll explore the relationship between technology and new developments in oceanography. And looking ahead, we'll discuss possible applications of recent discoveries within the ocean and examine how recent discoveries in abyssal zones have impacted scientific theories. So we have a pretty good idea of how the oceans work overall. If we take a step back and look at the ocean as a whole, we can predict how things are going to work. We know how they function in general. But it's the small scale, the local scale, that we don't really have a lot of information about. That's where these AUEs, or autonomous underwater explorers, come into play. These are miniature robots. And these miniature robots are going to go around and collect ocean data on a smaller local scale. This is the first kind of small-scale study of the ocean. Now, these are going to be about the size of a soccer ball or smaller. And Jules Jaffé says AUEs will provide a whole new kind of information. And that's exactly what we're looking for. We're looking for any sort of new information that will help us better understand how our oceans function. So then we have the Nereus. Now the Nereus is a new type of machine that has the ability to dive to depths that we've never been able to do before. So it's a new type of unmanned deep-sea robot that was able to dive to nearly 11,000 meters, which is roughly equal to 6.8 miles. Now that might not sound like a big deal to you, but previously, before the Nereus was developed, our maximum depth was about 4 miles. So it's improved our ability to investigate and explore the deeper parts of our ocean. So it allows us to research virtually unexplored ocean realms. It allows us to see what kind of species are down there. There are definitely going to be species down there that we have never seen before. It's also going to allow us to see the physical and chemical characteristics of the deep ocean. Then we have our hybrids. Now when I'm talking about hybrid, I'm not talking about like a hybrid car that kind of works on electricity and also gasoline. No, we're talking about hybrids whether they're controlled by people or whether they're automatic. So we have the AUVs, which are automatic underwater vehicles. Now if you can kind of imagine an airplane flying underwater, these automatic or autonomous underwater vehicles kind of go around by themselves, and they can explore on their own, collecting information. Then we have the ROVs, which are remotely operated vehicles, which need to be controlled by a person on the surface. And these can be converted from one to the other. They can either be autonomous, going around by themselves, or remotely controlled. So it helps us collect data, sampling of things in the deep ocean, and experimentation. So the U.S. Integrated Ocean Observing System, or the IOOS, is a partnership between federal, regional, and private agencies to increase our understanding of our oceans and coasts and the Great Lakes, to improve safety, to enhance the economy by enhancing economic output of our oceans, and to protect the environment. So when we're talking about science and how technology can help us to improve our knowledge of the oceans, a great study to talk about is the U.S. Joint Global Ocean Flux Study, which took place from the late 1980s to 2005. It studied ocean carbon cycle. See, oceans have a significant impact on the levels of atmosphere gases. So it's very important to study how the ocean interacts with our carbon cycle. So concentrations and changes or fluxes of carbon and associated nutrients in the ocean are some things that this study looked at. We have limited knowledge of this ocean biochemistry. This is a new wave of ocean science that is being born, and there's going to be many jobs that are created in order to keep this science moving in a forward direction. Resulted in the synthesis of a modeling project, which is SMP. So thinking ahead to the next section. How are new discoveries within the oceans being applied? And how are new deep sea discoveries impacting current scientific theories?